Alright, so now we're going to talk about our second unit of concentration, molarity. Now keep in mind, molarity is abbreviated with a capital M. Make sure I can tell the difference between your lowercase m's and your capital M's. Molarity is equal to your moles of solute over your liters of solution. So it's moles per liter. Solute over solution. Now that looks like a conversion factor, right? It changes from one set of units to another set of units. And that's exactly like what we're going to be using it as, a conversion factor, just like we used our percent concentrations. One thing I want to point out, the abbreviation for moles is MOL. Okay? It is not M. Remember, M is meter. So don't use the M. Make sure if you mean moles, you can write it out MOL. Okay? Let's see about using this new unit as a conversion factor. So let's work a problem. I'm going to pull out the information as we get to it. Describe how to prepare 2-liter solution, so 2 liters of this solution. So the 2 liters refers to the amount of the solution. And the solution happens to be 0.15 molar, capital M. Okay, and it's a solution of sodium hydroxide, so it's going to be sodium hydroxide in water. And we've got our molar mass here of sodium hydroxide. I assume by now everyone understands how to calculate molar mass and can do that on their own. If not, always reach out to me and we can go over that again. So now we've pulled out all the information, and now we need to think about how we're going to work this problem. So the first thing with every concentration unit, or every concentration problem, is get those units into something you can cross out. So molarity you can't do anything with, but if we change this to moles of solute per liter of solution, now it's a conversion factor. We can work with that. Okay? Just like we saw with percent concentration, we're going to most likely, in most cases, we're going to start with the number that's not the conversion factor. That's this guy up here. So we've got 2.0 liters of solution. Solution's in the top, so where does it have to be to cancel out? Has to be in the bottom. So we're going to put our liter of solution on the bottom. That means the other thing goes on the other side of the line. Moles of solute. Liters of solution cancels out with liters of solution. The only unit we have left is moles of solute. Okay, that's not quite where we want to go, but it's getting there. So let's go ahead and take the 2 times the 0.15, and we end up with 0.30 moles of solute. Okay. Now, can we go in the laboratory and measure out moles of solute? Well, no, we can't. There's no way to measure that. But we can go into the laboratory and measure out grams. We've got a balance. So, is there a way we can get moles to grams? Absolutely, our molar mass. So that's the number right there. A lot of times the molar mass won't be provided for you, so you will have to know that you need to calculate it from the periodic table, and then use it in the calculation. So we've got 0.3 moles of solute. In this case, the solute is sodium hydroxide. Okay. So we're going to use the molar mass of the sodium hydroxide. Moles are on the top, so moles have to be in the bottom to cancel out. We're going to put our 1 mole in the bottom and our 40.00 grams in the top there. And moles of sodium hydroxide cancels out. Now we've got grams of sodium hydroxide. It's the only unit we have not canceled out. So we can do that calculation, 0.3 times 40, and we get 12. It's 0.30, so 2 significant figures. So in the end, we need 12 grams of sodium hydroxide. Is that what the problem asked us for? Well, not quite. It said describe how you're going to prepare the solution. Now, yes, we needed to do this calculation to find out how much sodium hydroxide is there. So to prepare the solution, you would take 12 grams of sodium hydroxide, put it in a 2-liter volumetric flask, add some water to dissolve the sodium hydroxide. Then once it's dissolved, then bring it to the final volume of 2 liters. Okay. Now I left out some words there just so it wouldn't take me so much time, but that's the type of answer with all those words in there that I'd expect on an assessment. Okay. So be very careful about what the question is asking. Make sure you're answering the question. Okay. How to make a solution is always going to have those steps. Put the solid in the correct sized volumetric flask. Add a little bit of the solvent. Dissolve it. Only after it's dissolved do you bring it up to the final volume. And there was a slide on this that we've already covered. So hopefully you're familiar with that process. Let's go ahead and do another problem. I'll move down here. This problem says, if the concentration of sodium chloride in blood is 0.15 molar. So we know the solution is going to be blood, and this is the concentration of the blood. What volume in liters, so what we're looking for is how many liters, contains 2.0 grams of sodium chloride. Remember, the sodium chloride is our solute. So we want to make sure we label everything correctly. The other thing we got to do, get those concentration units into a conversion factor. So 0.14 moles of solute per liter of solution. Okay? We're going to start with the thing that's not the conversion factor most of the time. So we're going to start with the 2.0 grams of our solute. Solute's on the top, so where does it have to be to cancel out? Well, it has to be on the bottom. So we're going to have to flip this conversion factor over. So we put 0.14 moles of solute in the bottom. And we've got liters of solution in the top. Now, we've got grams here of solute. We've got moles of solute. Do grams and moles cancel out? No, but we do have conversion factors. So we can convert grams to moles, and we can do that with the molar mass. And the molar mass, we've got sodium, which is 22.99, and chloride, which is 35.45. We can add those guys up. And we get 58.44 grams per mole. So grams are on the top, grams have to be on the bottom to cancel out. And we're talking about the sodium chloride, the solute. And the 1 mole goes on the other side, again, of the solute. Moles of solute cancel out moles of solute, grams of solute with grams of solute. And the only thing we haven't canceled out is liters of solution. That is what we were asked for, so let's go ahead and do the math. We've got 2 times 1 divided by 0.14 divided by 58.44, and we get 0.24 liters of solution, because we can only have 2 significant figures. So we did two calculations here using molarity. Here I did it in 2 steps. Found the moles and then did the final calculation. Here I did it in 1 step, just stacking those conversion factors. So you can do it either way as long as you do both sets of conversions. Okay? So let's go ahead and work a few more problems. Here we've got a dilution problem, which is just like the dilution problem we had on the other using the percent concentrations. It says, how do you prepare 200 milliliters of this solution? So this is one solution, and we've got to prepare it from a stock solution that has a concentration of this guy. That's the second solution. Okay. So we can draw our little picture. One solution we've got 2 numbers for. The other solution we only have 1 number for. Okay. So we're going to first of all get these guys into numbers that we can actually use. Moles of solute per liter of solution. And this is 6.0 moles of solute per liter of solution. So just like the last problem, the amount of solute here equals the amount of solute here. Okay. So we are going to figure out how much solute is here and use that as the second number for this one. So our first step is to find out how much solute is in solution where we have 2 numbers. Okay. So we're going to start with the number that's not the conversion factor, 200 milliliters. Volume, this is milliliters of the solution. I should specify. If we don't specify what it is, we don't know how to put our conversion factor in there. Milliliters of solution, so we need volume of solution on the bottom. So we've got liters of solution. And then the other thing goes on the other side of the line. Now, we've got volume and volume, but milliliters doesn't cancel out with liters. So we need a conversion factor in there. Milliliters is on the top, so we need milliliters in the bottom. Liters is on the bottom, so we need it in the top. Our conversion factor is 1 of the big guy to 1,000 of the little guys. Now our milliliters cancel out, our liters cancel out, and this gives us how much of solute is in that first solution. 200 times 3.5 divided by 1,000, and we get 0.70 moles of solute. Now that's the number we use in our second calculation. So in our second calculation, we're going to start off with the number we just calculated. That's how many moles of solute we need. And we're going to use our second solution concentration. So we've got moles on the bottom. We need we've got moles on top. Let me move this down so you can see it. Moles are on top, so we need moles in the bottom to cancel out. So we have to take our conversion factor here and flip it. We're going to put 6.0 moles of solute per liter of solution. The moles cancel out. The only thing left is liters of solution. So we can do that calculation, 0.7 divided by 6, and we get 0.12 liters of solution. Okay. Now it asked us for how to make this solution, so we're going to take 0.12 liters of this solution, add water until we get to a final value volume of 200 milliliters.